Right, and coming up next, I'd like to introduce Sudip, who's going to talk to us about testing from into the kernel. And apparently, if we ask very nicely, he's got some open hardware to show us as well. So, Sudip, thank you very much.
Yeah, good morning, everyone. First of all, an announcement: someone has lost the phone. It was found outside. So, if anyone, please get it from you. Anyway, so this is going to be a talk about testing. Not some complicated architecture stuff or security, because testing, we believe testing is the key to have a stable release, or if you want to maintain an image or a package for a long time, testing is the key for that. But first of all, who am I? My introduction. So my name is Sudip. My IRC nick is also very surprisingly Sudip. I've got a couple of emails which I have listed over there. So I'm working at Codethink for almost 8 years now. I joined as a kernel engineer, but now that has become kernel and everything else. Oops, what happened? Sorry. So that has now become kernel and everything else. So builds, integration, debugging, user space, kernels, everything. But anyway, that was rewarding because that got me involved with Debian and became a Debian developer for those reasons. So, like I said, I joined Codethink as a kernel engineer. And before joining Codethink, I used to be a regular contributor to the Linux kernel. And I used to see that many of my patches were getting added to the LTS tree, the long-term stable kernel tree. But at that time, the LTS kernel was not getting that much of testing. I think only Gwenter or Shua used to test the LTS kernel at that time. So I decided to test the LTS kernel myself and send the test reports. So this was my first test report. I missed something in the reports. Any guesses, anyone?
What was wrong?
Yes. I missed something. Well, I just said that I tested and I booted. I didn't say it worked or not. So Greg replied back asking it's working. So yeah, that was my first one 8 years ago. But now, after 8 years, these are my test reports now. So thanks to Codethink, I have got access to multiple runners, which can cross-compile the kernel for multiple architectures. These built kernels are then booted on real hardwares or QEMU and tested. So this is for one of the LTS test. I also test the mainline kernel Linux tree every night. And also those reports are being sent out. So those reports are sent out only when there is some build problems. Linux has specifically asked not to send the reports every day. So this is second part of the GitLab pipeline that we are running. So these are just some of the jobs. I could not fit all the jobs in this screenshot. So I'll open another tab and I can show that. So the build stage here is building for multiple architectures and multiple configs with multiple compilers. You can see I'm building with CLang, I'm building with GCC 11, GCC 12, GCC 13, all kinds of architectures and all configurations. The report stage, the second stage over there, that is collecting all the logs and it's giving me a summary of all the errors from a failed job. And that is easier for me because I am pasting those errors in the report mail that I send out to Greg. And the next stage, the GitLab starts the testing on the kernels. So we are using Lava for booting the kernel on a hardware and also using OpenQA for some of the other tests. So some of you already know what Lava is and what OpenQA is. I'll see if I can open another tab. 1 second. Okay, I can't, it seems. So anyone knows here what Lava is or has worked with Lava? Many of you, good. So Lava was initially developed by Linaro. It's only introduction for Lava for those people who does not know what Lava is. and is used for deploying the operating systems into physical and virtual hardware for running tests. Now, tests can be as simple as a boot test or a complete system testing, which can include running LTP. LTP is a Linux test project, or if you want to run stressng, or any other test which is using done from command line. Now, we have a very simple test system, and as of now, we only have 3 devices connected, one Raspberry Pi, one MIPS CI20, and one unmatched board. But the Lava, which is managed by Linaro, that has almost 86 devices. So last time I checked, they had 86 online devices and like 200-something devices offline which were in maintenance. So that's a huge setup. But Lava and Linaro, the one which they are maintaining, they have their workers running everywhere, so not just in their office. So this is what a Lava workflow looks like. So the user from the web interface has a web interface, and from there he can trigger a job. There is a job definitions in the Lava server. So Lava server will then contact the appropriate worker, which contains the device, and the job definition defines which device has to be used. The worker then controls a PDU. PDU is for powering off and powering on the device, and that can be anything relay based or Wi-Fi based. We are using something Wi-Fi based. Okay. This is the part of the Lava test that we are doing. This is part of the Lava definitions. We use the U-boot method to get to a U-boot console. Now, Lava can have multiple boot configurations or boot testing and can support multiple bootloaders. So in our case, we are using U-boot method. So Lava interrupts the U-boot while it is booting up and goes to the U-boot console. And it then asks the U-boot to load the kernel, the device tree, and the modules via TFTP. Lava internally will set up a TFTP server, and that will be set up just for that particular job, and will send that link to the U-boot. So after it reaches the login prompt, it will give the username and password as that is defined in the job definition. And then it will interact with the interactive test commands. Lava is mainly designed to use consoles, so it cannot use anything which is graphical. You can log in, you can use the test console using the interactive test commands, but you cannot use any mouse or keyboard and cannot test if the mouse, keyboards, or display is working or not. And this is where OpenQA comes in. So OpenQA, you already know Phil is working with OpenQA here. There is one OpenQA Debian instance. So OpenQA, the architecture of OpenQA is almost same as Lava. It has a web interface which can view the test. It's responsible for sending the jobs to workers. Workers will then create virtual machines for tests if it is a QEMU-based job. You can also use hardware-based jobs here, and it will try to connect via VNC. So VNC is the default protocol for OpenQA. And even if it's running a virtual machine via QEMU, it will connect via VNC to get to the graphical interface. The tests are mostly graphical, and the job definitions, the tests are defined in Perl. Okay, not. So worker will then do the actual test, they collect the results, and send these back to the server. I will show some job definitions and job results afterwards. The job log in the server will have screenshots of each test and a video of the machine's display. Internally, the OpenQA will be comparing each screenshot to needles. Needles are defined in the test, and those are the reference screenshots, and it will compare based on how much percentage it has. It is same as the reference needle. It will say the test has passed or not. So this is what the OpenQA workflow looks like. So the user will be on the web interface. Server connects to the multiple workers. It has a database to store all the information, all the test, all the device information. It will use the OS autoinst to start the test and connect to our Raspberry Pi or QEMU via VNC. In our case, the tests are defined in a separate repo so that it is not dependent on that particular worker, and it just clones the repo every time we start the test. Okay. This is from one of our QEMU-based job, which tests the kernel. So the first line here, this is where the OpenQA boots up the QEMU with the default image. In the second one, it will then download the new kernel from our GitLab. It's done over here via console. And then installs it. And since this is snapshot-based volume, so the original image for the VM is unaffected, and we can use the same image next time. So after installing the kernel, it will then reboot with the new kernel. That's done over here in the second part. It will go to the grub, and it will control grub, give the key up or key down, and boot to the particular new kernel. And the test will then check if we have reached the login screen or not. If we can reach the login screen, then it tests if the desktop screen is displayed or not. If the desktop screen is displayed, then it will test the mouse clicks are working or not. So it will just click on the top left of the screen and see if the menu and the search box is displayed. If that test passes, then it will connect to the QEMU via SSH and will get the message. Okay. So now our objective is to test the new kernel on a real hardware. But just booting the kernel is not enough. So we need to know the graphical interface is working or not. So Lava can boot a device with a new kernel, but Lava cannot test the graphical interface. OpenQA can test the graphical interface, but cannot boot the hardware with a new kernel. So we have to combine both of them together and have a system where Lava will boot the device, and then we'll hand over the control to OpenQA, so that OpenQA can test the device and confirm that the graphical interface and everything is still working with the new kernel. And this is what our workflow now looks like. So GitLab builds the kernel. Then the job triggers the test in the Lava. And that is being done using Lava CLI. Lava then downloads the kernel, boots the hardware, executes a script which will trigger the OpenQA test. Now, the test I'm triggering from the device itself, because that is also acting as one of the interactive tests, so that it knows those commands are also working. The OpenQA needs to know the IP address of the board because it needs to connect to the VNC. Because otherwise, without VNC, it cannot use the display. This is the Raspberry Pi jobs on the OpenQA, so which runs every night and tests the Raspberry Pi with the mainline kernel. The LTS jobs are only triggered when Greg sends the RC release mails. Otherwise, they are not run every night. But the mainline jobs runs every night. This is one of the jobs for the Raspberry Pi. As before, this is only testing the desktop and the mouse event works or not. The SSH is in the second line. It gets the login via SSH and saves the message. Now, this is only testing the kernel without changing anything in the rootfs. And I enable the remote desktop so that OpenQA can communicate with VNC. So this remote desktop enabling had been done before, and I had a chance to pre-configure the image. But that was only the kernel testing. But now, since I am a DD, so I should also be testing Debian. And testing the Debian unstable is the first choice because that has not been released yet. That is going to have lots of bugs, which is, well, unstable. So, sorry, I'll go back to the previous step. So these are the steps that I decided to follow. So we get the image from Raspberry Pi, flash it to the Raspberry Pi image, Raspberry Pi board, boot the board, and test the graphical interface with OpenQA. So, but the problem here is that the Debian Raspberry Pi image builds and publishes the daily images, but the images are based on Trixie. that is Debian testing, but there are no images from Debian Unstable. So I had to look at how the Raspberry Pi team is generating the images. So they are using a tool called VMDB2, which takes the YML file as an input. The YML file defines what the image will have, the image size, everything that has been installed in the image, or how the image is being configured after installation. The spec that the Raspberry Pi team uses is in Salsa. So the link is over there if someone is interested. VMDB2 is using dbootstrap to create the base image, and then using BeanFMT support to configure that image and install extra packages, creating new users. I have to create a new user for login. Now the slide showing these two build times, 40 minutes and 9 minutes. So 40 minutes was on an x86-64 machine with BeanFMT. But if I do the same build on an ARM machine, ARM64 machine, then that completes in 9 minutes. So now we have a Raspberry Pi image from Unstable built from scratch every night. Next step is to flash it to the Raspberry Pi so that it can boot the image. I can just take the SD card and DD to it, but I need to automate the process so that the CI, it can be run from CI. And I also need to have a fallback so that I can recover the board remotely if the image does not boot. So for that, I decided to use the USB boot capability. The Raspberry Pi 4 supports Raspberry Pi boards, I think, all the Raspberry Pi 3 even. It supports booting from USB. You just need to enable it from the firmware. So I need to boot flash the image to the USB drive from GitLab CI. The image in the SD card is going to work as my backup image. And now the problem is, how do I write the image to the USB drive from the GitLab CI and then connect the USB drive back to the Raspberry Pi board so that it can boot? And this is where this comes in. So Codethink was working on this USB switch for another project, and then that was made completely open source. Hardware, firmware, everything is open source. So I don't have this hardware with me right now, but that's the picture of it. So it has a control port on the top, on that side. The control port, when connected to a laptop, it will register as a TTY SEM device. The USB drive is connected to the top port, that port over there. And the bottom two ports, one of them is connected to the laptop, another is connected to the Raspberry Pi. And this is what it's going to look like. So the USB drive is now going to switch between these two devices, whatever is connected. So in my case, one is laptop, one is Raspberry Pi. And switching between the Raspberry Pi and the laptop is just a matter of giving those two AT commands. So AT plus port equals to 1 will switch to this one, the first port. AT plus port equals to 2 will switch the device to the second port. So, and it just needs a GitLab runner. So the GitLab runner was installed in that same laptop. So the laptop now has the GitLab runner, the control port, and one of the other port. So the GitLab CI now just needs to give the AT command and can control where the USB drive is connected, either to the laptop or to the Raspberry Pi. So that is going to solve my USB flashing problem. So now we have the image. We have a way to flash the image to the USB drive. We have a way to connect the device to the board. Booting is simple, just power it on, which Lava can do. But how the OpenQA is now going to test the display? Because the YML spec, the default YML spec used by the Raspberry Pi team is CLI based. It does not install any graphical interface. So I modified that to install XFCE4. It was a little bit less heavy than the others. So, and the LightDM as the display manager. So on our previous OpenQA-based test, we were only testing the kernel. So I had a chance to pre-configure the image to enable the remote desktop. But in this case, the unstable image is being created every night from scratch, and I will not have any chance to configure that image to enable the remote desktop. So I need something which can interact with OpenQA and control the graphical interface so that I can run the tests. And this is where QAD now comes in. So we were working on a similar problem before for one of our client project. And there we had to test it without modifying the image. And at that time, QAD was started. And later QAD was made open source. So that was my plan to add it in the test plan. QAD internally uses a HTTP server. It receives the requests from whoever is sending the request via HTTP. It can also use certificate-based if you want authentication. Based on this request, it then either passes it to a JSON parser, or if it is a screenshot request, then it directly sends it to the backend. Backend is a KMS backend, which is using libdrm, and it gets the dump from the left frame buffer, and which it then uses libpng to make a PNG image and sends it back to the requester. QAD is still getting developed. It's last time I checked that it only supported the screenshots and mouse events, and it also supports other touchscreen events like swipe and everything. The version that we have in Debian does not support keyboard entry, but I think I saw an upstream merge request to add that support, but that's still under development. It's not yet tested fully. So I modified the vmdb2 YML file and to add installation of QAD over there, and also had to modify it further to add a service file so that the QAD starts up on boot up on a particular port. Now this communication is via HTTP, so I need to define a port over there which OpenQA can communicate to QAD. So now this is my final GitLab pipeline. For the first job, builds the image. Second job, flashes it. Third job, tests the image. And the fourth job, restores the previous image. So this is what the job internally looks like. So please feel free to interrupt me if you think that I'm doing something completely stupid over here, or it can be improved in some other way. So it's a very simple job. It just installs everything that vmdb2 needs, and then runs vmdb2 to generate the image, and the image is then passed to the artifact so that the next job can pick it up. That's the second job. It takes the image from the previous job, marks the Raspberry Pi as in the health maintenance mode in Lava so that the other jobs cannot start any other new test on Lava. Gives the AT command to switch the USB drive to laptop, and then just uses DD to write to it. After writing is complete, it will then switch it back to the Raspberry Pi. The Docker image that I have used over there, the USB switch latest, that is just a bookworm image with Lava CLI and Python 3 OpenQA client installed. Okay, this is the main job that is actually triggering the Lava job for testing. It uses Lava CLI to submit the job, and the script that job_state that monitors the job until the job has started running. Because after submitting the job, it stays in a scheduled state for some time, and then it starts running. So now we need to know the IP address of the Raspberry Pi so that we can trigger the OpenQA job. Because OpenQA needs to know the IP address so that it can communicate to QAD via VNC. Sorry, not via VNC, because our QAD has its own backend, which I had to install in OpenQA. So in the interactive test and the Lava jobs, I'm printing the IP address, which the rpi quad.py that is being modified to insert the IP address into that one. And that script is then executed, which will trigger the OpenQA job. So the IP address I'm fetching from here. Okay, this job is same as the flashing job. It will just switch the USB drive to the laptop, writes back the original image, so that the other kernel tests can run over there, because the mainline test will run every night. The delay of 5 minutes over there is there because it's still not complete. I'm not yet monitoring the OpenQA job, which I should be doing. So 5 minutes is, for now, it's enough for the job, but as it's in my to-do list to add a monitoring state over there so that I can check if the OpenQA job is still running or has completed, and then complete this task after the OpenQA job has finished. And this is what the final OpenQA job looks like. So this just boots, goes to checks the desktop is running. If the desktop is running, then it clicks on the menu and sees the menu is displayed or not. Very simple test. And so this is what my current setup looks like. So I have a laptop. The laptop has USB switch. My USB switch has got 2 USB cables connected and another USB cable from the Raspberry Pi for the serial port. Now I'm working on adding another board, and when I have that board connected, my setup is going to look like this. So laptop is now having USB hub because my laptop won't have those many USB connections. USB hub will now have 2 cables to one of the USB switch, 2 cables to another USB switch. Now USB switch is connected to Raspberry Pi and another USB switch connected to the second device. Both the devices now are giving the serial port to the laptop. Now, this is just with 2 devices. Now, once I add a third device, it's going to get quite unmanageable. So, this is called TIAB, testing in a box. It's a Rockchip-based ARM board, and it can work as a Lava worker. It can work as an OpenQA worker. I can stack multiple, like this way, I can stack multiple USB switches and the USB hub on top of each other. So I have a board here right now, the box here. So this is the Rockchip board, the base layer. This is the USB switch. I can stack multiple switches on top of each other if I want. This works as the USB hub. This works as the USB hub. So this also I can stack multiple hubs on top of each other. So I can, just one box now can give me multiple switches and multiple hubs all together. So my setup is now going to look like this. I can have multiple devices. It will just connect over here. All the cables will go to TIAB, and I don't need to have USB hubs or multiple USB switches scattered across my desk. So my limitations are, if I have to add new boards, my only limitation I can think of is that the board needs to support booting via USB in my current setup. If the board does not support USB booting, then I cannot add it to this setup, and I don't know how to use that. And that is the reason I could not add this test for the MIPS CI20 device, because that is via SD card, and I don't know how to do that for this case. Since all my setups is done on GitLab, so if anyone wants to copy this setup, it can easily be done on Salsa. You just need to have a runner or TIAB or anything. I think that's the end of my slides. I can show some of the... 1 second. Can I? Yeah. How do I... Oops. Okay, that's bad. How do I... I don't think I can maximize this, can I? No. Yeah. Nothing is working now. It's completely gone. Okay, great. It's not even responding now. Okay, fine. I'll remove this one and have this one now. Great. No. Yeah, anyway, so, yeah. Can I do that? No. Okay, anyway, so this is what I wanted to show. Like, this is one of the bug reports that we sent for the LTS from the builds. The build failed, so this is where my summary job was helping me, because the summary job was showing off all the logs, which I pasted over here. This is for one of the mainline kernel builds, which failed again, and I had to send the report to Linus and everyone else. This is what the Lava job looks like. I cannot maximize it. Really sorry, but sorry.
Nope.
No. No.
Yeah.
Some reason. Anyway, so this is what the Lava is looking like. All the jobs here. The links are all in the slide, so I'll upload the slide to the wiki. So that's okay. This is what the OpenQA job. So OpenQA job will test everything. I do have time, right? Yeah. Ow. Come on. Anyway, so this is the login screen it checks for, and then after login, it will check the desktop screen has reached. It will then download the kernel over here, installs it, and then it will reboot. Rebooting is done over here. It again goes to grub menu. It's doing the keyboard presses for going to the particular kernel, and then booting up and seeing again the graphics and everything is working. This is for a mainline, the Raspberry Pi. It just sees the graphics, the desktop screen is working, and checks for the menu, the keyboard. This is what the job looks like, but okay, I cannot show it here, so forget that. Great. Okay, let me just try to open tab here and see. Okay, this is the job that was triggered today morning for the Raspberry Pi and the Debian unstable. So it boots up, it finds the desktop, it then checks that the menu is working, and that's it. So it was done today morning. So I think that's it. So any questions?
So I think I speak for everybody here when I say thank you very much for doing this testing. It's awesome. It's really good to see it happening. You mentioned that you've now got a really nice USB switch, but some of the other platforms, USB is not the right way, and you need SD cards and bits and pieces. There are various SD card switches in existence.
We tried one of
All
them.
of the ones I've seen are flaky as hell.
Yes, exactly. Exactly.
I'm happy to work with you if you fancy building one from scratch. If you want an open project on that as well.
Over there.
Daniel. God, I've got to work with Rob and Daniel again. But yes, thank you.
Great.
Any
Thanks.
questions? Yep.
Have you ever considered using USB gadget for emulating a USB device? So instead of having a switch, you can have, for example, a Raspberry Pi with USB gadget emulating a USB pen drive, and also you can use the same Raspberry Pi for connecting through serial port, and then your Raspberry Pi which is going to be the equivalent of the current of a server what we use in Chrome OS, you can connect through Ethernet.
Yes, that
and then you can
be done.
escalate.
Yeah, I think can be done. I think we have not considered that, but can be done, I think. Okay, yeah.
Yes, we tried that, but the performance is terrible. And some of the boards that we use this same infrastructure for testing have software updates that are 16, 32 gigabytes big, and we might be testing 80 builds in a day. So having a USB 3 super speed switch and using a fast USB stick is just so much quicker.
I'll also add to that, Gadget D, whilst it's great, doesn't necessarily give you the hidden partitions, hidden files and bits and pieces, and it only supports it as a single file structure. If you need special bits hidden in places on USB sticks, it doesn't necessarily work.
I think you can emulate like a complete block device, and in that block device you can put whatever you want. Your file system will be on top of that.
Yeah, okay. I stand corrected. It's changed.
How do you ensure stuff goes to the correct device? Do you have some kind of device IDs on these USB switches that you code into your configs so that you can make sure you flick the right switch and then write to the right USB stick and so on when you've got 2 or 3 of these things connected up?
Yes, that is something which I thought of, and I have not used that yet. But we can use the USB path. So when the USB is connected, the control port is connected. The UDEV will have from the UDEV rules. You can have you can decide which TTY SEM has been divided has been registered for that particular port, and we can then somehow we have to use that, and maybe some UDEV rules will have it. Name it some way. I think Daniel has something.
The USB switch firmware has serial numbers in it, so if you set up UDEV rules to say, okay, the switch with the serial number should be, TTY RPi, and another one should be TTY Badgerboard 2, and so on, then it can do that. I'm now going to do my stooge question. You mentioned that the USB switch is open source. What about that testing in a box?
It is. It is. I had the link somewhere in my slide, so only if I can open that again.
So all of that, including the mechanicals and everything, is open, and we encourage people to build their own and to add new boards and let us know what fun things you've been doing. We have CAN interfaces and all sorts of things for that as well, which is pretty fun if you're into automotive, which isn't fun.
What I should say is what Sudip described as the USB hub on top is also a HID emulator, and it has JTAG and serial ports and all sorts of stuff on it, so you can lash it up to almost anything.
For my use, USB hub is enough. That's it.
So, as I understand, this is running daily on a Lava pipeline, or
Yes.
Would it be possible to hook it up into auto package test so that when a package breaks booting on the Pi or whatever device, it would block testing migration, the maintainer would get a report, and things wouldn't break in testing, or the maintainer would notice earlier? I understand that this is running on real hardware, so it'd be a little more difficult, and maybe it's not supported by auto package test at the moment, but maybe a new kind of test could be added that says this is going to have to run on.
I guess that can be done, but that is not going to test all the packages, right? Because currently I'm just testing the graphical interface. So based on the package, I think that can be done. Why not? We need to have a specific hook in the auto package test for, I don't know, maybe something to discuss with the release team, and Paul and Phil is also there. So something jointly I think can be done, surely. If there is nothing else, then I think I'll stop.